All right, so today we're going to talk about some of the basics of blood pressure. And if we have time, we're going to get into the cardiac cycle. This may have to wait till the next lesson, but we'll see if we can get started today. You have a blood pressure lab in 4 days. In order to do that blood pressure lab properly, you're going to need to know exactly what you're doing. And that's what today is all about. Okay. When your heart is actually beating, there's a lot of pressure. If I were to say that this is a chamber, you don't need to draw this. If this chamber was empty versus a chamber that is full, which one would you predict to have more pressure? The empty chamber that like no blood in the chamber versus the chamber that had blood filled all the way to the top. Which one had more pressure? Yes. The one that's full has more pressure. When your blood vessels, your veins, your arteries, your capillaries, and the various chambers of your heart are filled with blood, they have a greater pressure. Right now, as you guys are wearing your t-shirts and your sweaters, there's more pressure being applied to your clothing while you are inside your clothes versus when your clothes are just hanging in your closet. There's nothing inside of them. So generally, when we have an object inside of a larger object, the larger object is experiencing more pressure. The smaller object is exerting pressure on it. Your feet are exerting pressure on your shoes. The pencil lead in your pencils is exerting pressure on the lead. The water in your bottles is exerting pressure on the sides of the bottle. When we come to actually measuring blood pressure, there's two values that we will be looking for. The first is going to be the systolic pressure. This can also be termed your systole. Systolic pressure is a period of contraction. This is going to be the larger number, like the actual greater value. You may have heard the template blood pressure, the prototypical blood pressure is 120/80. The 120 is your systolic number. So this is the larger number. It's on top. When I say on top, like if I have X over Y, it's X. Now, when it comes to pressure and contracting, the chambers are filled with blood. A chamber or chambers are filled with blood. In order to fill a chamber with blood, the valve that is at the end of the chamber must be closed. So I want you to try to visualize that heart in your mind again. I want to ask you, when an atria contracts, it is pushing blood forward. Whenever you hear contraction of the heart, it's pushing blood to the next stop. So if a right atrium or a left atrium were to contract, can you tell me what valves must be open in order for that blood to actually pass through it? The AV valves. So the AV valves must be open. On the other hand, when ventricles contract, what valves follow the ventricles and allows blood to move on to the next area? The semilunar valves. The semilunar valves are open. If you had an atrium contract and blood was not able to leave, that's like squeezing your water bottle with the cap still on. The pressure is going to build up. Okay. The opposite of systolic pressure is diastolic pressure. This is going to be a period of relaxation. This is the number that will be on the bottom. This will be the smaller number. So when I say X over Y, it's Y. 120 over 80, it's 80. This is when heart chambers have the heart chambers are empty. Now, if a chamber is empty, is there any need to pass on empty contents forward? No. So would you expect the valves to be open or closed? Closed. When the atria relaxes, the AV valves are closed. When the ventricles contract, excuse me, I don't mean to say contract, relax. The SL valves are closed. The atria can be in systole or diastole, and the ventricles can be in systole or diastole. It is possible for you to have a systolic number and a diastolic number to be like really far apart. That might mean that your heart is relaxed normally, but it generates a lot of pressure. So we'll be able to differentiate one number from another, and I'll give you guys a key to refer to determine if this is good or bad or what it means. Okay. Okay. The next topic I like to discuss is hypertension and hypotension. This all has to do with the strength or the weakness of blood pressure. So within a scale, you have kind of like the green zone. This is going to be normal blood pressure. Hopefully all of you are within this range. But there can be such thing as too much or not enough. Goldilocks and the Three Bears taught us this. Too hot, too cold, just right. This area that is above normal blood pressure is known as hypertension. In other words, this is high blood pressure. Is there anyone you guys know that naturally has high blood pressure? Is it natural or induced?
I don't actually know.
Who? You?
No,
Oh. Well, some causes can be genetic. My mom's side has high blood pressure. Like when they get angry, my uncle's eyeballs look like they're about to pop out of his skull. The vein in the top of his temple looks like it's about to burst, and he gets all red. Some can be diet. Would anyone happen to perhaps know the two main factors that you could have in your diet that can lead to high blood pressure? What?
Cholesterol.
You're close. You're close. Yeah, that leads to what I'm thinking of. Or opposite, what I'm thinking of leads to that. Saturated fats. Animal fats. Grease. Just grease. What else? It's more abundant in food in this country than almost in any other country. It's in, no, not sugar. Good guess. Salt. Sodium. You eat potato chips. You just can't stop one because you eat the salt. The salt is addicting. You put salt on your French fries, but I've had students who put salt on their cereal. It's ridiculous. Yes, and that leads to kidney stones, which is a topic we can get to later. It can also be activity or lack thereof. So Mackenzie's talked about cholesterol. Cholesterol is something that can definitely increase your blood pressure, and it can cause some major issues. Some of the diseases and disorders that hypertension can lead to, we'll talk about on Tuesday. There's two I want to get to: aneurysms and atherosclerosis. So let's talk about atherosclerosis first. I didn't expect to talk about this till next Tuesday when we do diseases and disorders of your cardiovascular system, but it comes into play here, so why not talk about it? So let's say here is a blood vessel. This is going to be a normal and happy blood vessel. We're going to have the blood flowing through. It's going to be nice. No impediments. No blockages, no nothing, no blood clots. Everything's going in one direction. This is going to be a very healthy blood vessel. Very good circulation. And on the other hand, we have an atherosclerotic vessel. What do you suppose is inside this blood vessel to make it not seem so healthy? Fat and cholesterol, same thing. Not good. Not good at all. Now, this is going to do a number on the pressure that's applied to your blood vessels. This can be pretty bad. There's a law that some of you may vaguely remember from chemistry. Some of you were in my chemistry classes, so I know I taught this. If you don't recall, I'll jog your memory, but there's a law called Boyle's law. This may look familiar to you. P1 times V1 equals P2 times V2. Have you ever seen that before? What Boyle's law basically means is that pressure and volume are inversely proportional. In other words, it means that whatever happens to volume, the opposite will happen to pressure, and vice versa. So volume is space occupied, and pressure is force applied against the surface. This Saturday, I have the bad kids, skippers, people cussing their teachers, stuff like that for Saturday work detail. And one of the jobs I make them do is they have to spray all the turtle poop out of the pond filter. Well, let's say here's the hose. You don't need to draw this hose. I just want you to watch. Here's the hose, and I want them to take that hose and spray, key in on the word spray, all the poop that's lodged inside that filter. Have any of you ever turned on a hose and it just comes out like this? You want to crank up the pressure so it can spray. What do? You put your thumb over it. That's what I do. So let's say that you put your thumb over the opening. Are you increasing or decreasing the volume, the space of the opening of the hose? You put your thumb in front of the opening of the hose. What are you doing to the actual space on the opening of the hose? Are you increasing it or decreasing it? This is a decrease in volume. So what will that do to the pressure of the water that is trying to escape that hose? It's an increase in pressure, which is what makes it spray. Have you ever filled up a balloon with air and you want to make it do all the little squeaky sounds? Is that when barely any air can escape or when a lot of air can escape? Barely any. You're decreasing the volume that the air can escape through, and it's going to increase the pressure. When you whistle versus you make your mouth smaller so that less air can escape, and so you have a greater pressure, and that greater pressure helps generate a sound. If you put your finger in front of the hose, it's going to spray out. So a decrease in volume is an increase in pressure. So let's go back to this blood vessel. Does this blood vessel have an increase or decrease in volume when compared to a normal blood vessel? A decrease in volume. So what happens to the pressure inside? The pressure inside is increasing. If this is the case, your heart is beating harder to push blood through these narrow passageways that are filled with fat and cholesterol and plaque. This can lead to an aneurysm where you have so much pressure built in, it pops. Like if you blow too much air into a balloon, you're increasing the pressure on the balloon. If you keep blowing air in the balloon could pop. That's an aneurysm. So it can lead to an aneurysm. An aneurysm is a burst blood vessel. I don't know if I shared this very tragic story with you guys. When I was in high school, there was two kids that were going to fight after school in a grocery store parking lot. And the bully said, "Meet me here after school. We're going to fight." And I don't know why, but the kid showed up. He had no interest in fighting. The bully punched the kid right here, side of the head. That's where your temple is. Now, if you got punched in the arm or punched in the gut or even punched in the cheek, you have cushion. You have meat and muscle and fat there. You have nothing here. And so basically the blood vessel in this kid's head was squeezed between his own skull and the bully's fist, and it burst. That was an aneurysm. And the kid was dead before he hit the ground. He was dead before he hit the ground. Every second that your brain goes without blood, brain cells die. Every second. It's not like you hold your breath and then they start to die. Every second they will die and they can't come back. So if you have a blood vessel that leads to your brain and the blood vessel has popped, you no longer have blood going to that part of your brain. That part of your brain is going to die. And that leads to another condition called a stroke. A stroke is when a part of your brain does not receive blood. That can be caused by an aneurysm. It can also be caused by this. A complete blockage. Now, not only does this happen in the brain, it can happen in your heart. What do you call it when this happens in your heart? It's a heart attack. And then you have to have something called the bypass surgery, which I'll get to on Tuesday, but I guess since I mentioned it, I should tell you. If you go to the Publix down here in Neptune and Neptune and Dale Mabry, they have construction going on there for more than a month. It's driving me crazy because after school on Friday, I go to Publix and I have to take a detour. A detour is like a bypass. So if there is a blockage right here in your heart, what doctors have to do is they have to take a blood vessel from somewhere else in your body. They have to stitch it here and they have to have the blood be rerouted and it goes around the blockage. And while that blood is flowing, they will open up this area and try to fix it. That's a bypass. You have up to 4 of these coronary arteries, which I'll teach you later this week. And so you can have a single, a double, a triple, or the big one, a quadruple bypass surgery. I know you can't see this if you're watching online, but these blood vessels that I'm pointing to here, these are called your coronary arteries. They actually deliver oxygen to your actual heart. Your heart has blood go through it, but your heart also needs blood. And so these blood vessels are coronary arteries. You got 1, 2, 3, and 4. And so if 1 is blocked, you got to have a single bypass. If 2 of them are blocked, it's a double, and then a triple, and then a quadruple. And that's major heart surgery. But none of you ever have to experience that. Okay, let's get to the opposite of hypertension, and that's going to be hypotension. This is the opposite side of the spectrum, the other danger zone. Now, being hypotensive could be a lot of things. Some causes. You could be, it could be genetic. It could be due to dehydration. I can feel it in my head right now. I probably have hypotension. I haven't had a drop of water all day, and so I can feel it in my head. I'm dehydrated. Your blood is mostly made out of water, and so if you don't have a lot of water in your blood, you're not going to have full volume. It can also be due to hemorrhaging, and this is the big one. Hemorrhaging is like having a leak. And if you have a leak, you're not going to have full volume. And I think this can best be explained by that hose example again. So let's say here's a hose. Okay. If there is not a hole or a kink anywhere in this hose, you would expect water to come out normally. But what if Sebastian were trying to water his little rose garden and he ripped open a hole in that hose, like he was dragging on the ground and got caught on a nail or something? And so he turns on the faucet, water's coming through, and then it just starts to leak out. What's going to happen to the amount of pressure that's coming out the other end of the hose here? Hardly any at all, because you have a leak. This is exactly what happens when you have your own circulatory system. If you're bleeding externally, like your arm is bleeding, your neck is bleeding, your leg is bleeding. You've seen the shows, you've seen the movies. What do they tell you to do when you have a bleed on the outside of your body? Put pressure on it, wrap a tourniquet around it, try to cut off the blood, the leaking of blood. If you are bleeding from your arm or your side, they're going to say, put pressure on. You're going to try to squeeze as hard as you can to make it seem as if there is no opening. You just put a lot of pressure on it to try to keep the blood in your body. Because as soon as blood exits your body, the pressure is going to go down. And your heart will not be able to generate enough pressure to push blood throughout your entire system because you're losing pressure out the side. On the other hand, if you had an internal bleed, that's even worse. If Nate was bleeding from his side, we can see that. Nate, you need to put pressure on your side. Hold your hands down there really tight. But what if he was bleeding internally? What are we supposed to do? Open him up, carefully move things around and hunt down the bleed? I mean, come on. So people that die of hemorrhaging, it's more often an internal hemorrhage. As when we began blood, I told you guys, you are not water balloons of blood. When you're watching Mortal Kombat or 300, you see blood flying all over the place. That's not true. If you scratched yourself and not an ounce of blood came out of you, you did not get to a blood vessel. Lucky you. But imagine somebody was shot. They have bullets going through their blood vessels, and now their blood vessels are leaking everywhere, and it's just draining out of them. That blood's supposed to be going to your brain, your lungs, your organs, your muscles. Now it's all over the sidewalk, or it's leaking in a pocket inside your body, like a cavity. The blood pressure goes down, and your heart can't generate enough pressure to push it throughout your whole body. In those areas of your body that don't get blood pressure, die. So hemorrhaging is a major, major cause of low blood pressure. All right. So we have hypertension, hypotension, systolic, diastolic. We'll just do two more today. We're not going to get to cardiac cycle. It's a Monday. Let's do two more, and then we will call it a day, okay? Two more terms. Rapid and slowed heart rate. I can't remember if I did this last time. If I did, let's just do it again. So if this were a normal heart rate on someone, P, QRS, T, P, QRS, T, P, QRS, T. Okay. I want you guys to notice these intervals here, 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 and there. Those intervals have to be the same. So if I were to like say this aloud, this first one, which we're just gonna say is normal, quote unquote, it's gonna sound like this. Boop, 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 boop. And it's a consistent pattern. You can predict it. You can set your watch to it. Now, if you had a rapid heartbeat, this is called tachycardia. Tachycardia is where it's going really fast. Boop, 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 boop. And it's a constant pattern. You can set your watch to it. So if you look at the interval here, there's an interval there, 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 there. It's like there's not even a break. It just keeps going. Your heart can't rest. When you guys were checking your blood pressure or your beats per minute last week, I had someone in an earlier class just sitting there. Her resting heart rate was over 100. I was like, ooh, that might be tachycardia. She might have just rapid heart rate. On the other hand, I had some students that might have qualified as being considered bradycardia. Oh, by the way, I didn't define it, did I? Tachycardia is a rapid heart rate. And bradycardia is a slowed heart rate. This will look like this. You have the same interval all the way throughout. So it's boop, 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 boop. That is not necessarily a bad thing. Those of you who exercise, you like to go jogging on Bayshore, you eat healthy, it would not be surprising if you had bradycardia, and that doesn't mean, oh no, something's wrong. It just means like you're really in shape. Your heart does not have to struggle to push blood throughout your body. On the other hand, if you started out normal like this, boop, 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 and all of a sudden you started slowing down, that might be a sign your heart is not fully functioning. Maybe you have a leak somewhere, you're hemorrhaging. There's a lot of reasons and that's what doctors do. They get to the bottom of it. But if you have a consistent slow heart rate, I have a kid last period, he's in cross country. He might qualify as bradycardia. He had a really slow heart rate, but he's in great physical shape. He runs miles and miles a week. So his heart doesn't have to struggle. All right, we are going to stop there.